First step, we need to know which power line is the causing of the problem itself. Is it the IC power or the CPU or the NAND? Okay, firstly we will connect the phone to the power supply. If we got an ampere more than 0.1, like 100 milliampere, that means that the IC power is working correctly. Okay, in this case we will accuse a CPU or NAND. So we will connect the phone to the computer itself. If the computer read the phone, this means that the CPU is working probably. In this case, we will accuse the NAND. So we'll do the software to the NAND. Okay, in this case, we'll do a software to NAND. If the software didn't work, we are going to do a reballing hardware to the NAND. This is exactly how we will work on all power issues. We need to determine, is it IC power problem or CPU or NAND? Okay, if it IC power problem, it will be on the power supply less than 0.1, less than 100 milliampere. So we will work directly on the IC power, as we will see here. So if it less than 0.1 milliampere, we will go directly in the second step to work on the IC power, is to measure a volt on a power key. Okay, this is a voltage measure, as we see here, 0.8 volt, which means that the power key is working probably. Okay, so let me show you how to power on the phone without power key. Just get your tweezers and add it on the power key connector, and the other part on the ground. As we see here, the mobile is just powering on without a power key. As we see on the power supply here, the mobile is just running correctly. And as we see, 0.1, which means that the IC power is working probably. As we get a power 1.8 on the power key, also power key is working probably. So in the next step, we will just pressing on the IC. Maybe the phone take a damage or something happened to the phone itself, so we are going to press on the ICs, like the 3 ICs that we mentioned before, and keep your eye on the power supply itself. If the power supply go more than 0.1, this means that this IC is a problem. Okay, we are going to press on all IC, but just a light pressing. Okay, don't press so hard, just a light pressing. Then we are going to do a diode measure on a power route. Okay, as we see here. Okay, if we get a read on a diode and the other part will be infinite, this means that the route of power is also working correctly. Okay, in this case, the route is working correctly. If we got like infinite in both sides or reading on both sides, this means that the power route is not working. So this step is to make sure that the power route is working correctly, and in this case, we need also a schematic here. I will show you how to work without a schematic in next step. Okay, but this step is so important to just measure a diode on the IC route. In the last step is doing a randomly volt reading. As we see here, we just trying to measure a volt around a CPU. As we see, there is a 3 volt here, which means that the CPU, the IC power is working correctly, and it gives the volt to the CPU. And this is randomly without any kind of schematic. We are just going to make a multimeter on a volt mode, and we are going to measure on a capacitors around the CPU and NAND to make sure that they take the volt from the IC power, which means that the IC power is working correctly. And this is a way also to make sure which one is the problem here, which one we are going to work on. Okay, this is also another way. We will see like 3 ways in this video to make it easier for you. Okay, as you can see, there is 1.8 volt here on the capacitor, which means that the IC power is working probably, and he gives the volt to the CPU. As we can see here on the capacitor, there is a volt here, and there is 1.8 volt and 1.8 volt. 3.2, it means that it's working like 100% IC power is working. Okay, the problem here will be between CPU and NAND. And as we mentioned in the beginning of this video, to know which one is the problem, we're just gonna connect the phone to the computer to know which one exactly is the problem here. Is it the CPU or the NAND? Okay, and if it's a CPU problem, it will be easier than the NAND, because most of reballing will be easier to the CPU. Okay, we are going to find a lot of reballing material to the CPU itself. We are just still doing the randomly volting measure around the CPU to make sure that everything is working fine around the CPU. And we are going to test also the same way around the NAND. We are going to measure the voltage around the NAND. Okay? It is so easy, guys. Just let's do it around the NAND. As we can see, there is a voltage around the NAND here, 0.6 volt. And 0.6 volt also. Okay, there's 1.8 volt here, which means also that the NAND take the volt. Okay, here we are. NAND, we got voltage measure. Okay, 1.8 again. It means that the NAND take the volt from IC power. So IC power is working like 100%. There is no problem in IC power route. It's working like 100%. And we just know that, okay, there is a 3 volt here. It means that the NAND take like 100% of voltage here. Okay, so IC power in this case is working probably. And let's see if we have the schematic here. The schematic show you directly where to get the voltage as we did. We did this in the randomly volt, okay? But if we have the schematic, it will tell you directly where to find the volt. Okay, this is show you exactly as we did in the random volt. Okay, there is a 3.0 volt here as we found it. This is how we are going to make. And in case if you have the schematic itself, we are going to follow a voltage like this, how it shows in the schematic itself. We are going to follow a component after the component until we didn't find a volt in this component, which means that this component is the main accuser of this problem. In this case, we are going to take out this component and we will replace